Princesses and princes of Python, let's make you random number royalty by learning how to generate random numbers in CircuitPython. And while we're at it, we'll learn to generate non-repeating random numbers by leveraging the while loop. And we will end with a bonus build showing how you can apply what you've learned to make a cool, sparkly holiday ornament. Let's learn! So there are lots of reasons you might want to generate a random number. Maybe to generate a random value for a game, flash a random light, or trigger a sound after a random amount of time. And routines to do this and a whole lot more are built into the random library in CircuitPython. That's a built-in library, so you don't need to add anything to your CircuitPy volumes lib folder, and if you're using PyCharm, it's already in CircuitPython-stubs. And generating random numbers in CircuitPython is very easy. To get a random value between two values inclusive, you just use the randint function specifying the first value and the last value. Want to simulate a six-sided dice roll? You simply say random.randint and in between parentheses 1, 6. Another useful function is randrange. This can return an integer value for any valid Python range, and you can create the range using all three values if you wanted to, start, stop, and step. And as an example, you can pick a random light in a group of lights named pixels. You can simply call random.randrange, passing in len, the length function, with pixels inside of it. And in the examples we've been using up to this point, we've had 10 pixels on our CircuitPlayground board, so this would generate a range from 0 to 9, and would choose a value from 0 to 9 inclusive each time this line was called. Another thing you might want to do is make a random selection from a list or other sequence, and to do this, just say random.choice, passing in the name of the sequence between the parentheses. For example, if your code had the list of drum sounds from our previous lessons, random.choice between parentheses drum sounds would choose a single string from the list of strings. Now, one brief note, these functions work great for the randomization needs that most makers have in their projects. Games, lighting, setting random times, but do note that mathematically, these aren't technically considered to be true random values. They're considered pseudo-random values, and this is the case actually in most programming languages when you generate randoms. If you needed true randomization, say you were doing something like cryptography, generating ultra-secure passwords, then you'd need some more advanced routines in mathematics. But these routines are going to be great for us, and now that you know how randint works, let's have a challenge. Try to make the 10 lights on your CircuitPlayground sparkle like the one you see here, and the way to do that is to select a random light to flash white, then keep it on for 1/10 of a second, turn that light off, and then start over again, continuing to select random lights and flash them on and off. And when you're done, save this as random-sparkle.py. So why don't you pause the video and give this a try? I know you can do it. And let's resume and see how you did. And now to begin, plug in that CircuitPlayground board, Blue Fruiter Express, start up PyCharm. If you're new here, welcome. You may want to check out the prior lessons in the playlist to see how we got to this point. So back in PyCharm, I'm going to change the comment to random-sparkle. And this is going to be a small program, so I can delete everything else. And let's import our libraries, import board, time, neopixel, random. Then let's set up the neopixel lights on our board. We'll do that by creating an object we call pixels, setting that equal to neopixels dot capital N neo capital P pixels, and in parentheses board dot all caps neopixel, 10, because there are 10 lights on the board. And then let's create the color white in all caps. We'll set that equal to, in parentheses, 255, 255, 255. And under that, we'll set the color black equal to, and in parentheses, at 0, 0, 0. Then in our while true loop, while capital T true colon. And so we've got 10 lights on our CircuitPlayground. We want to get a number from 0 to 9 because those lights are numbered from 0 to 9. There are a bunch of different ways we can do this. Why don't we put the random number from 0 to 9 in a variable called random_light, and we'll set this equal to random dot, and I'm going to use randrange. And between parens, I'm going to pass in len, the length function, and between those parentheses, I'm going to pass in pixels, which is the variable representing our neopixel object. Now the length of pixels is 10, and remember, if we put a 10 into the range function, that generates values from 0 to 9, up to but not including 10, and each time we call this, a random value from 0 to 9 is going to be generated and put inside of random_light. Then on the next line, I'll say pixels, in between square brackets, random_light, setting this equal to white in all caps. Then we'll wait 1/10 of a second with time.sleep, passing in 0.1. Then we should turn off the light that we just turned on, so we can say pixels, bracket, random_light, close bracket, equals black, all caps. And why don't we also print out the value for the random light after it's generated? So right after the call to randrange, I'm going to say print, passing in random_light. And let's open the terminal, make sure TO is running, save, and look at that sparkly goodness. So I'm going to let this run for a few seconds. And then I'll Control C to stop. And watch what happens if we scroll up. So we can see that there are a few repeated values in here, and I'm sure your numbers are different. But you can see right at the end, I've repeated 6 twice, I've repeated 3 twice. A little further up, I've repeated numbers again. So I'll Control D to get out of the REPL. My code starts running again. There are numbers. I'm going to close the terminal. So the next thing we want to do is to make sure that the last value that we lit up isn't repeated. Now, before I show you how to do that, why don't we go ahead and save this to our CircuitPython school folder as random-sparkle, and we can close that outermost tab and get back to code.py. Now, in order to get this to work, we want to compare the last light that we lit up, and we're going to keep track of this in a variable that we call last_light, to the random light value that we've just chosen, and we've been storing that in a variable that we're calling random_light. Now, when we start our program and before we enter our infinite loop, we haven't lit up any of the lights. So I'm going to set the value of last_light equal to -1. That's a value that doesn't exist. Now look at our loop. The outermost loop, our while true loop, is infinite. It repeats everything indented below this as long as true equals true, which is always the case. So this is always going to repeat. Then the first thing that we do is generate a new value for random_light. That's the light we want to flash. But then we have another while loop, and this is not an infinite loop. It will repeat the lines indented below, and in this case it's only one line, as long as this condition is true, while last light is equal to random light. That's the value we just generated above. Double equal sign means equal to or is the same as. So with that double equal sign, this is going to be either true or false. And if it's true, these two values are the same, we don't want to light up random light. So what we're going to do is repeat this loop and generate another random light. And we're going to keep checking it over and over again until we get a false value here. And that occurs when last light does not equal random light. If that happens, we know we have a non-repeated value. It doesn't equal the last light. Then we skip what's indented, we're going to print the value, we turn on the light for our random light, which we now know is not the same as the last light. We sleep, turn off the light, but also, very important, we want to set the new value of last light to random light, the value we just lit up. We do that because the random light is now the last light we lit up. Then we go back here to the start of the infinite loop, we generate a new value, we compare this to our last value. If they're the same, we keep generating new random values until we get a different value than the last light, and this pattern continues over and over again forever because it's inside of an infinite loop. So we've got a while loop that may or may not execute what's inside of it, so this is not an infinite loop. It could be true, it could be false, and that loop is inside of an infinite loop that's always going to be true. So hopefully that's clear. Let's code this up and try it out. So I'm going to change the comment up top to read non-repeating-random-sparkle.py. And we want a variable to keep track of the last light that was lit up. So I'm going to call this last_light and set this equal to -1. And again, we don't set it to a legitimate light like 0, because if we try to compare 0 to the last light that was lit up, we would never have 0 as our first light. Not a big deal, but it's more true with the spirit of what we want to generate if we consider all of the lights to be the first light that would be started up, and -1 is never going to be a random value that's generated. Then in our while true loop, below our first line where we generate a new value for random_light, we're going to introduce that second while loop. We'll say while last_light double equal sign, meaning is equal to, random_light colon. Remember, this checks to see if the last light that was lit up is the same as the random value we generated above. And if that's the case, then what we want to do is we want to generate a new value for random_light. So that's just the same as the first line in our while true statement. I'm going to copy this, paste it indented below the while last light equals random light. And what this is going to do is it's going to repeat this one indented line as long as the last light is equal to the random light. Most of the time this is not going to be the case, but about 10% of the time you're going to generate a random light that was the same as the last light, and if that happens, you'll go inside the while loop and repeat this, generating a new random light until the condition above is false. Now everything else is going to be the same, but we need one more line in here, and I've seen a lot of students forget this last line. Remember, we now want to take last_light and set this equal to random_light, because the last light that we lit up is now random light. Then we repeat the while true loop, we get a new value for random light, we compare it to the last light, and if these two things are equal, we'll generate new random lights until they're not equal, When they're not equal, we know we got a new value for random light, so we can light it up, then turn it off, and reset last light to random light. That's it. Let's open the terminal and check this out, and we can see these values are running. And for some reason, even though I saved, it's not restarting my work. Let me put an extra space in here and try to save again. And sometimes that does it. Sometimes you just have to add another space and try to do an extra save in there. Sometimes you can quit out and get back in. But we're running. Look at this. And it's sparkling up fine. And if you Control-C to take a look, you shouldn't see any values that are repeated in here. The while loop takes care of that. Nice! So let's save non-repeating random sparkle to our CircuitPython school folder and close the outermost tab. So now that you've coded this, you've actually written the code that you can use for a sparkling holiday ornament. As a bonus, here's how to build one. So here I am attaching my CPB to a LiPo battery so that it can run as a portable project without having to be plugged into the computer. And if you use a LiPo battery, just a bit of a warning, be careful. They can be dangerous. They can explode if they're punctured or overheated. So be sure to read up online for safety tips. And if you buy a LiPo battery, you'll also want to buy one of these charging boards so that you can recharge it too. Then I'm going to wrap my CPB and battery inside some simple baking parchment paper that will diffuse the light. Then I'm going to put it inside of this plastic holiday ornament, and Adafruit sells these in the perfect size to hold the CPB. Now I'm going to fill the other side of this ornament with these transparent craft beads that I got from a Michael's Craft store. They're going to diffuse the light even more, and when you put these sides together, you've got a lovely ornament that you've coded yourself. Quite festive, worthy of a celebration of your continued coding awesomeness. Keep at it, and if you build something based on what you learn in these videos, you can post something to Threads, Instagram, or Mastodon with the BuiltWithProfG hashtag, and you might win the weekly Happy Gear sticker drawing. But once again, Festive Coder, we've had lots of big learning. We learned to use the random library functions of randint, randrange, and choice. We used while loops for non-repeating values, and we learned how we could build a holiday ornament with just a few more low-cost parts. So get out there and make something awesome.